Resistance is a property of a wire that opposes a flow of electric current, and it depends on several factors, including the length of the wire, the thickness of the wire, the material it is made from, and the temperature of the wire. In this experiment, we want to find out how the resistance of a wire changes when we change only the length of the wire while keeping everything else the same. When electrons flow through a metal wire, they move forward by colliding with the metal ions inside the wire, and every collision slows them down. The more collisions the electrons experience, the higher the resistance becomes. A longer wire contains more metal ions, and therefore electrons collide more frequently, which increases the resistance. A shorter wire contains fewer ions, and the electrons collide less often, so the resistance is lower. In this practical, a length of wire is connected into a circuit with a power supply, an ammeter, and a voltmeter. We measure the current flowing through the wire and the potential difference across it. Using the equation R equals V divided by I, we can calculate the resistance. We repeat this experiment with different lengths of the same wire, such as 10 centimeters, 20 centimeters, 30 centimeters, and so on, and keeping all other factors constant. To make the test fair, we must use the same thickness of wire, the same material of wire, and make sure the wire does not heat up too much, because temperature can also increase resistance. After collecting our results, we would expect to see that as the length of the wire increases, the resistance also increases in a direct relationship. If we plotted a graph with resistance on the y-axis and wire length on the x-axis, we would see an upward rising straight line. The conclusion of this experiment is that the resistance of a wire is directly proportional to its length, meaning that doubling the length of the wire doubles its resistance. This knowledge is important in electrical engineering and electronics because longer wires waste more energy and can reduce the efficiency of devices. Understanding resistance helps us design safer and more efficient circuits and allows us to select the best wire for different purposes in real life.